P factor, also known as asymmetric disk loading, is a left turning tendency resulting from the descending propeller blade's higher angle of attack, which creates more thrust, than the opposite, ascending propeller blades when the TBM is at high pitch attitudes. The left turning tendency is strongest at low airspeeds, such as during takeoff roll after the pitch-up rotation, and during steep initial climbs at low airspeeds, such as Vx and Vy. As the angle of attack is reduced, less and less rudder force is required to counteract the left turning tendency. The propeller slipstream exists throughout the speed envelope and creates a nose left turning tendency, which is pronounced at low airspeeds and decreases proportionally with increases in speed. Torque influences roll about the longitudinal axis, a counterclockwise rotation of the fuselage when viewed from the cockpit. It is also predominant at low airspeeds. Respecting rotation speed and minimum approach speed provides control authority against the effects of torque. Aggressive pitch-up transitions, as in a rapid rotation at takeoff, creates a nose-right turning tendency, gyroscopic precession. The same is true with aggressive pitch-down transitions, as with a brisk stall recovery. But the turning tendency would be to the left. The effect is also more pronounced at low airspeeds. Understanding the flight control inputs required to counteract the left yawing tendencies created by P factor and slipstream is straightforward. Right rudder force is required. Gyroscopic precession, another yawing tendency, is apparent during pitch changes, thus it is momentary. Brief right or left rudder force is required. Torque, which is most obvious with an abrupt increase in power, is different. Torque induces roll and is strongest when flying slowly, when the weather vaning properties of an airplane are at a minimum. Earlier we mentioned that the primary flight controls used to roll an airplane were the ailerons, which is true. Unfortunately, ailerons have two byproducts which are undesirable when flying at minimum controllable airspeed. Ailerons increase angle of attack, and they produce adverse yaw. On all airplanes, the lifting aileron increases the angle of attack at the associated outboard wing section. Lift is manipulated to roll an airplane. Therefore, if one is truly flying at minimum controllable airspeed, any increase in the wing's angle of attack would exceed the critical angle of attack, resulting in a wing stall. Moreover, if the critical angle of attack is exceeded by the lifting aileron, a stall results and the airplane rolls in the direction of the stall. Applying more aileron worsens the situation. Regarding adverse yaw, when increasing lift, an aileron also induces drag, which pulls or drags the nose of the airplane in the opposite direction to the roll. In this example, if one wanted to roll to the right, to wings level, the nose would yaw to the left, against the desired direction of movement. This is also an undesired effect when maintaining coordinated flight at minimum controllable airspeed. The TBM's advanced aerodynamic design incorporates spoilerons, which assist with roll control and mitigate adverse yaw. Despite this aerodynamic advantage, one should manage propellers' rolling and yawing tendencies by giving the rudder priority for roll control when maneuvering in the low-speed regime. This image of a TBM 850 was taken during the initial stages of the takeoff run. Power is at 100% torque. Soft field takeoff technique is being applied. For the purposes of this review, the pitch attitude is set. Indicated airspeed is accelerating through 55 knots. The aircraft is light on fuel. Payload is at a minimum, and only the pilot is on board. Since the aircraft is light, with a high power setting at a low airspeed, the optimum conditions exist for the propeller's effects on the airframe. Can you visualize the angle between the thrust vector and the flight path? In this example, the flight path is the ground run. With power at 100%, the left turning tendency resulting from P factor is at a maximum. With maximum power and minimum aerodynamic control due to the low airspeed, a strong slipstream is curving around the fuselage and impacting the side of the tail, inducing a left turning tendency. With a high power setting and low airspeed, the rolling tendency caused by torque is at a maximum. It is easy to see the wingtip clearance, or look even closer at the difference in the strut compressions. See the rotation of the fuselage. The wide stance of the TBM's main landing gear provides stability against torque during the takeoff roll. Since the pitch attitude is set and not in a pitch transition, gyroscopic precession is at a minimum. The left turning tendencies induced by a propeller are real and well pronounced at low airspeeds. Proper use of trim settings during takeoff reduces the control forces required to maintain aircraft control. As an airplane slows below reference approach speed, less than 1.3 VSO, the ailerons become less efficient. However, the rudder's secondary effect, contributing to roll control, becomes primary. Finesse is required to avoid over-controlling an airplane. If not managing the rudder properly, abrupt applications of either the flight controls and/or power when flying at the edge of the envelope could pitch, roll, or yaw an airplane forcefully enough to induce and aggravate a stall. Having viewed this video in its entirety, you are now aware. With respect to airmanship and managing propeller tendencies, there are 3 levels of engagement: passive, reactive, and active. A passive pilot allows a propeller to alter the path and orientation of the airplane without taking corrective action. A reactive pilot recognizes that the orientation of the airplane has been displaced and returns it to the desired position with the correct flight control inputs. An active pilot understands and anticipates the tendencies of the propeller. Furthermore, he or she immediately counteracts any influence the propeller has on the airframe in order to maintain coordinated flight. Only one question remains.